everyone. Welcome to Swam's online lecture series on the topic Database Management System. I am Muhammad Udullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University. I am welcoming you all today in this lecture as today we explore some very important topics. In the next few minutes, we will discuss today the data modeling using the relational algebra, fundamental operators, and also join. So we the end of today's lecture. So by the end of today's lecture, we will able to understand the concept of relational algebra and fundamental of operation of database management system. In the previous session, we have discussed the concept of relational model concepts, relational model constraints, and integrity constraints. Before proceeding with today's agenda, I would like to discuss that the questions that I had given you in the last class for practice and revision purpose. The first question was, what do you mean by relational model concepts and explain in detail? The answer is, the relational model in database management system organizes data into tables with row and column, facilitating easy retrieval and manipulation. Key concepts includes entities represented as tables, attributes as a column, and relationship linking tables. Each table has primary key, ensuring uniqueness. Normalization minimizes the redundancy and dependency issues. The model supports operations like select, project, join, and set operations for the data retrieval. Integrity constraints maintain the data accuracy. ACID properties ensure transaction reliability. Relational algebra and relational calculus provide theoretical foundations. Overall, the relational model offers a structured approach to database design, promoting data consistency, integrity, and efficiency in managing information. Explain relational model constraints in detail. Relational model constraints in database management system enforce rules says. Relational model constraints in database management system enforce rules on data to maintain integrity and consistency. Key constraint includes primary key, foreign key, unique key, check, not null, prevent not null, constraint enhancing data quality, prevent anomalies, and uphold relational integrity, ensuring accurate and meaningful data representation. By enforcing these rules, the relational model guarantees that the reliability and coherence of database crucial for efficient data management and reliable decision making. The next question was, what is the primary purpose of constraint in the relational model of database management system? The answer is, constraint in the relational data model of database management system serve the primary purpose of maintaining data integrity and consistency by enforcing rules such as uniqueness, referential integrity, data validity, and null prevention. Constraints ensure that the data stored in the database remains accurate, reliable, and meaningful. They prevent anomalies such as data duplication, inconsistent references, and invalid entries, thereby promoting data quality and reliability. Constraints plays a crucial role in upholding the relational integrity of database, facilitating efficient data management, reliable query, and consistent decision-making processes. The last question was, what are the integrity constraints in the database management system and how they ensure data integrity and consistency? The answer is, integrity constraints in database management system enforce rules on the data to maintain its accuracy and reliability. These constraints include primary key, foreign key, unique, check, and not null constraints. They ensure data integrity by preventing duplicates, inconsistent, or invalid entries, maintaining relational integrity, and upholding predefined data standards. By enforcing these rules, integrity constraints mitigate the risk of data anomalies and ensure that the database remains consistent and reliable. This promotes trustworthiness in the data, facilitating effective decision making processes and supporting the overall integrity of the database system. So now let's begin. The agenda of the today's lecture is to discuss relational algebra and fundamental operators. So very first we will discuss relational algebra. Relational algebra in database management system is a theoretical framework for querying and manipulating relational databases. Relational algebra in database management system is a theoretical framework for querying and manipulating relational databases. It consists of operators like selection, projection, union, intersection, differences, join, and division. Selection retrieves rows that satisfy specified conditions, while projection extracts specific columns. Set operations like union, intersection, and differences combine or compare tuples from different relations. Join combines tuples from multiple relations based on a common attributes. Division is used for complex queries involving multiple relations. Relational algebra provides a formal mathematical foundation for query optimization and evaluation in relational database systems, enabling efficient data retrieval and manipulation. Moreover, this we must know some other important about relational algebra as relational algebra is a procedure query language. Relational algebra mainly provides a theoretical foundation for relational database and structured query language. The main purpose of using relational algebra is to define operators that transform one or more input relations into an output relation. Given that these operators accept relations as input and produce relations as output, they can be combined and used to express potentially complex queries that transform potentially many input relations whose data are stored in the database into a single output relation, the query result. Now let's understand an important segment of today's lecture, which is fundamental operation in detail. Fundamental operators in relational algebra are essential components for querying and manipulating data within a relational database management system. These operators provide a structured framework for expressing relations on relations and driving desired information from the database. The core operator includes selection, which filters rows based on the specified conditions, and projection, which extracts specific columns from relation while discarding others. Union combines tuples from two relations, removing duplicates. It means remove the redundancy, while intersection combines tuples from two relations based on a common attributes, facilitating the merging of related data. These fundamental operators enable user to formulate precise queries and perform various operations to extract meaningful information from the database, forming the basic of effective data retrieval and manipulation. There are the fundamental operators used in relational algebra, which you can see in your screen. Selection, projection, union, set difference, set intersection, rename, Cartesian product, join. So now let me explain each operator in detail so you are able to understand them. So the first one is the selection. Selection is the fundamental operator in relational algebra used to filter row and a relation. Selection is a fundamental operator in a relational algebra used to filter rows from a relation based on specified conditions. It allows user to retrieve only those tuples that meet a specific criteria, thus reducing the size of the relation and focusing on the relevant data. For example, in a database containing information about employees, a selection operation may be used to retrieve only those employees who work in the marketing department or whose salary exceeds a certain threshold. Selection plays a crucial role in formulating precise queries and refining results set to meet the requirement of various applications. It enables user to extract meaningful information from the database by filtering out inherent data. It enables user to extract meaningful information from the database by filtering out irrelevant data. It is used to select required tuples of the relations. For the above relation, selection C greater than 3 in a relation R will select the tuples which have C more than 3. The selection operator only select the required tuples but does not display them. For display, the data projection operator is used. Projection we represent as a pi. Projection is the fundamental operator in a relational algebra used to extract a specific column from the relation table while discarding others. It allows user to focus on a subset of attributes within a relation, resulting in a new relation with a narrow scope. For example, in a database containing information about the employees, a projection operations may be used to retrieve only the employee name and their respective salary, discarding other attributes such as employee ID, departments of hire dates. Projection is essential for data manipulation and query optimization in relational databases. It enables users to tailor query results to their specific needs, reducing data redundancy and improving query performance by limiting the amount of information processed. Additionally, projection facilitates data privacy by revealing only relevant attributes to user or applications. It is used to project required column data from relation. Suppose we want a column B and C from relation R. Then pi B, C within parentheses will show the column you will see on the screen, and by default, the projection removes the duplicate data. Another operator is union operator. Let's understand it with the help of the example. Union is the fundamental operator in relational algebra used to combine tuples from two relations, resulting in a new relation that contains all unique tuples from both input relations. It enables the merging of data from multiple sources while eliminating duplicate tuples. The union operator is represented using the letter U and applied to the relations. Suppose we take the example French and German. It produces a relation containing all tuples that are present in either French or German or both. Duplicate tuples are automatically removed in the result, ensuring that each tuple appears only once. Union is particularly useful for combining data from multiple sources or performing operations such as data integration or data aggregation. It allows user to consolidate information from different parts of the database or even from different databases together, facilitating comprehensive analysis and decision making. For example, consider two relations, one containing information about the employee in the department A and other containing information about employee in the department B. By applying the union operator, we can combine these two relations to create a single relation containing all employees from the both departments. Union operations in a relational algebra is the same as union operation in the set theory. The only constraint in the union of the two relations is that both relations must have the same set of attributes, as you can see. Set difference. Set difference is a fundamental operator in the relational algebra used to retrieve tuples that are presented in one relation but not in another. It enables user to identify and extract unique tuples from the first relation that do not have corresponding tuples in the second relation. The set difference operator is represented using by symbol minus when applied to two relations. I have taken an example of French and German. It produces a new relation containing all tuples that we represent in French but not in German. The resulting relation includes only those tuples that exist exclusively in the first relation and excluded any tuples that are common to both relations or present only in the second relation. Now understand this operator with the help of one example. Consider two relations, one containing a list of all employees, another containing a list of employees who have received award. By applying this set difference operator, by applying this difference operator, you can retrieve a list of employees who have not received any award by subtracting the tuples from the second relation from the tuples in the first relation. Set difference is available for identifying uniqueness. Set difference is available for define set difference. Set difference is available for identifying unique and exceptional data point within a data set. It helps user isolate a specific subset of data that meets certain criteria or conditions, aiding in the data analysis, anomaly detection, and decision making processes within a relational database management system. Set difference in a relational algebra is the same as difference operator as in the set theory. The only constraint in the set difference between two relations is that both the relations must have the same set of attributes. Set intersection. Set intersection is the fundamental and very important operator in relational algebra used to retrieve tuples that are common to two relations. It enables user to find and extract tuples that exist in both input relation, resulting in a new relation containing only those shared tuples. It enables user to find and extract tuples that exist in both input relations, resulting in a new relation containing only those shared tuples. The set intersection operator is represented by using symbol AND. When applied to two relations, French and German, it produces a new relation containing all tuples that are presented in both French and German table. The resulting relation includes only those tuples that are common in both input relations. Consider another example. Two relation, one containing a list of employees who have been working for more than 5 years, another containing a list of employees who have received promotions. By applying the set intersection operator, you can retrieve a list of employees who have both worked for more than 5 years and received promotion, as these tuples are common to both input relations. Set intersection is valuable for identifying shared data point or commonalities within at least data set. It helps user. Set intersection is valuable for identifying shared data points or commonalities within a data set. It helps user find intersections between different subsets of data, facilitating data analysis, comparison, and decision-making processes within a relational algebra. Set intersection is a relational algebra is the same as intersection operation in theory. Rename, you can say row. Rename is a fundamental operators in relational algebra used to change the name of attributes in the relation. It allows user to assign new name to one or more attributes without altering the underlying data. The rename operator is represented using the Greek word row followed by a list of attributes name pair enclosed in parentheses. Each pair consists of the original attributes name and the new name assigned to it. For example, consider a relation containing information about employees with attributes such as employee ID, first name, and last name. If you want to rename the employee ID attributes ID, you can use rename operator as follows. Row within parentheses ID belong to employee ID from the table employee. This operation creates a new relation with the same data but the employee ID attributes renamed to ID. Rename is useful for improving the readability and clarity of queries, especially rename is useful for improving the reliability and clarity. Rename is unary operator used for renaming attributes of a relation. And if writing row A belongs to B R, then it rename the attributes B for the relation by A. Cartesian product. Cartesian product is a fundamental and crucial operator in relational algebra used to combine every tuples from one relation with every tuples from another relation. It results in a new relation when each tuple from the first relation is paired with every tuple from the second relation, creating a complete cross product of the two sets. Cartesian product operator is represented by a symbol X. When applied to two relations A and B, it produces a new relation containing all possible combination of tuple A and B. The resulting relation has cardinality equal to the product of the cardinality of A and B. Cross product between two relations, let's say A and B. So the cross product between A and B will be result in all the attributes of A followed by each attributes of B. Each record of A will pair with the every record of B.